we go about to solve question 14. Okay, in this case, there's a mass of 0.6 kg rolling down the hill. So it's talking about this object. Okay, it has a mass of 0.6 kg, and it's actually when it's 2 meters above the bottom of the hill. So it's talking about this height. The speed of the ball is 3 meters per second. So at this position, 2 meters away from the bottom, it has a speed of 3 meters per second. Okay, the question looks a bit complicated, but it's good to break it down into a few parts later on. Okay, so let's focus on the question. What is the kinetic energy of the ball? Okay, keyword is very important. At the bottom of the hill, it's talking about when it rolls down, it's going to hit somewhere here. Okay, so it's going to move somewhere and it hits here. So this is the question about its KE. So how much KE does it have at the bottom? Okay, they give me another information called gravitational field strength. So what is this 10 Newton per kg? This is actually the G. Okay, the G, and not any effects of friction. Okay, so how do we solve this question? There are so much information here. So how do we go about to solve it? So we must this is quite complicated. So we have to analyze. If you say this position originally is position A, this later position is position B. Okay, we go back to that question that we have done before. Is the principle of conservation energy. It says that total energy remains constant. So in this case, if we ignore whatever effect of friction, my total energy, if I talk about position A, okay, is actually my GPE, okay, and my KE. Why is that a KE? Okay, because at position A, this ball is actually moving with a certain speed. So when it moves, it has a kinetic energy. Why? Because when we look at kinetic energy, it's actually half mv squared, and this GPE is by its height. So there's a height and there's a v. So there's height of mgh. So at position A, there are actually two things happening. One is because of the height difference, which is 2 meters. So this is my h. And one is because at the height difference of 2 meters, it's really moving. So this is a very important key. So when it's moved, it has a speed of v. Okay. So for this position, okay, it has already mgh. So we take out, if we just substitute the values, so 0.6, g in this case is 10. Okay, it's a constant number. Height is 2, so I work out this part. Okay, mgh, and don't stop here because I need to add my half times my 0.6. I need to also multiply by my speed. So in this case, my speed is actually, you notice my speed is 3 meters per second. So I take 3, and remember, you must always square it, v squared. So if I press my calculator, now, 0.6 times 10 times 2, it gives me 12. Okay, if I take half times 0.6 times 9, 3 squared is actually 9, I get 2.7. Okay, so if I add these two values together, I get 14.7 joule. Okay, so this is my total energy at position A. But please take note, what I want is position B. So position B, you notice, the difference between position A and position B is that the total energy at position B is actually equal to only my KE. Why? Because at the bottom of the hill, it has a GPE which is equal to 0. Why? Because there's no height difference between the bottom of the hill to the position of the ball. So my GP is 0. So if I need to work out, I'll just work out my total energy, which is equal to my KE of the ball at position B. Okay, so how do we work out now? Okay, to work out this part, you have to equate to half times my mass, which is 0.6, and I multiply by my okay, in this case, okay, I can actually stop here. Sorry, I can actually stop here because the question is actually asking, we go back to the question, it's only asking for kinetic energy. So I can actually stop here because my KE is actually my total energy at position B. Do you notice? My position B actually give me my total energy at position A. Okay, because total energy remains constant at different position of the hill. So the answer in this case is actually part D. Okay. This question looks a bit complicated, but if you can recall, you just take note. Total energy is just the sum of the GPE and KE. So at position A, because it has both height, take note there's both height and there's both speed. So as a result, when we talk about energy at B, it's actually only KE because my height is actually 0. So my GP is 0, so my total energy is actually my KE. So if I just calculate very carefully, press my calculator very carefully, I'll get the answer 14.7. You can try it on your own. Okay, so the answer is D. Okay, that's all for question